So good morning everyone. Welcome back to the class of EGDL. So as I told you, you were supposed to solve one problem on application related to hexagonal lamina. So I have posted in the YouTube channel already. I'll be sharing the link today after the class. Okay, so see that the last set of questions which were assigned to you, in that there was one problem related to hexagonal lamina, hexagonal based. You will solve that part also. So after that, the part which was left out in projection of planes was related to the circular lamina. So I have posted the video links for circular lamina also. I'll be just describing you all how to solve it, and a little bit of introduction to projection of solids will start up with today, so that from the next class we can start with projection of solids. So this is the part what I have felt to cover in this sessions, to brief out the concept description for application problem on hexagonal lamina and circular lamina problems. The videos related to that are uploaded. I will share the link later. Okay, so let me take the screenshot of the attendance. Just a second. Hope everyone have typed your name and USN. In between also I will take once more before the session ends. Currently I can see only 26 participants out of 31. Where are the others? Yeah, hope the screen is readable from your end. Hello? Is the share visible? Screen share of the problem.
Yes, ma'am.
Okay, so this is a problem on hexagonal lamina. So this is application based. So you have two types, two problems on hexagonal lamina, which is application oriented. Both are same. In one they have given inclination with respect to HP, and in other they have given you just the location of 45 mm above HP. So that is the difference. Remaining entire construction part of the hexagonal lamina is similar. So I explained you in the video as well. In the video I have forgotten to name these letters. So I'll just explain you those. Accordingly you will complete the last problem of the last set of assignments which were assigned to you. So now read the question. It is a regular hexagonal lamina of side 30 mm, and it is told it is lying in such a way that one of its side touches both the reference plane. They haven't given whether they are resting in HP or resting in VP to start with the first stage, second stage and third stage of the hexagonal lamina. It is just told one of the side will touch both the reference plane. So the reference plane here are, one is our vertical plane and the horizontal plane. So one side, if you consider one side, this as a side, so this side is lying both in VP as well as HP. So that should be the position. It is not stage 1, stage 2, stage 3. And apart from that hint, what they have given is the lamina makes 60° with HP. Usually if this is a problem on first stage and second stage and third stage, they do provide the surface makes an inclination with HP. It is the entire lamina which is making 60° with HP. That shows they have given the information about the side view, not the inclination with respect to HP and VP. Since this is the issue, you cannot go with a regular process where you solve the problem in 3 stages. When it is a problem on 3 stages, they provide you whether it is resting in HP or in VP, and they give the surface inclination with respect to HP and the description whether they will give either the inclination with VP or they will ascertain you which side is been inclined to VP or which side is parallel to VP. Then you will do the third stage. This is a regular process which we follow. But in this case, they have just given the information stating that one of the side lies in VP as well as HP, and the lamina is inclined to 60 degree to HP. So they have given the information about the side view and the position, how does it look. So based on that, now you should plan how to construct the given problem. So here, since they have told it is a regular hexagonal lamina, first you will construct a regular hexagonal lamina, and it is, you are sure that it lies in both the planes, because one side is resting, sorry, it is not resting, one side touches both the vertical plane and horizontal plane. So you can figure out the lamina in both the planes. So here, since the side view is given, we usually start up with the front view. So since then you will construct such that one side is on XY line. So you will draw a straight line of 30 mm. Right, so after drawing a straight line of 30 mm, you will take the interior angle of 120 degree both the side. I am speaking about the dark line which is being drawn here. Okay, so just draw a straight line of 30 mm. From there you take interior angle of 120, interior angle of 120. So draw a line for 120 degree line. So then the side is given as 30 mm. So you just measure 30 mm and cut an arc. You just measure 30 mm and cut an arc. Similar process to construct an hexagonal lamina. So from there again you take 120 degree both the sides. So draw a line 120 degree and 120 degree interior. So again you measure 30 mm and cut an arc. On this 120 degree line you measure 30 mm and cut an arc. So both endpoints you have, you can blindly join it, even that will be 30 mm. So you have just constructed an hexagonal lamina here of 30 mm, stating that one of the side touches VP. So now similarly the other side should touch HP. So you cannot blindly project and cover it and leave. No, you should be having some projection line where it lies. For that it is very essential you will take the help of the side view. So to take the help of the side view, you have to draw one more reference plane, what we call it as x1 and y1. The first reference plane, always you name it as x and y. Don't forget to write VP and HP. After that only please start constructing the hexagonal lamina. So after you do construct, leave some space. You please do the naming. Don't forget to do the naming. A dash, B dash, C dash, D dash, E dash and F dash. Do the naming. So once you do the naming, you take the projections. So before taking the projection, you see that you have drawn the second reference plane x1 and y1. So after drawing the second reference plane, so from this point, you have to take now the lamina which is making 60 degree with HP. So you take the side view of 60 degree to HP. So once you draw 60 degree to HP, you have to trace out the projection of the hexagonal lamina of the front view to that of the side view. So you take the projection. This is already on XY line. You'll take the projection from A dash and D dash and see where it meets. You take the projection of F dash and E dash and you say where it meets. So where it meets you have to give the naming, and I have told you always the side view is represented by the suffix double dash. So here it was A dash and D dash, but here you have to write as A double dash and D double dash. Okay, so here when the observer views from the side, okay, if you view from the left, then only you will show the side view in the right profile plane. Okay, so now he is viewing from the left. A dash and D dash lies along the same line. Since he is viewing from here, A dash will be visible. You will write outside the bracket. Since D dash is on the same line, D dash won't be visible. So that you will write it within the bracket. So you will name here A, it should be A double dash. They have shown only A dash. Write it as A double dash. A double dash and D dash. Similarly, when the observer views from here, F dash and E dash is on the same line. F dash will be visible, but E dash will be hidden. So when you project this in the side view, you have to write F double dash and E double dash. So you now got the side views. And similarly, this point, you have B dash and C dash here. So when the observer views from here, B dash will be visible and C dash will be hidden. So you will write B double dash outside and C double dash inside. Okay, so you did the naming of it. After doing the naming, what is our ultimate goal? We have to show one more side in the horizontal plane also. For that you need the projection down. So how you can extend the projection of side view to our top view basically? So only the option is we have to take a 45-degree line. So you will take a 45-degree line and take the projection down from both the points. Okay, so after taking the projection down, you will extend the projection here back side 1 and 2. So after you do extend the projection back side, so what you will do, you will extend the projection from here also. A dash, B dash, C dash, D dash, E dash and C dash come along the same line. F dash and B dash also come along the same line. So you can read the locus, right? So you have A double dash here. A double dash is meeting with A dash over here. So this will be our point A. And D double dash is meeting with the locus of D dash here. So this will be our point D. And we have F double dash meeting with the locus of F dash here. So this will be our point F. E double dash is meeting with the locus of E dash over here. So this will be our point E. And we have here B double dash and C double dash. So B double dash and C double dash is on our XY line. And B dash and C dash is also on our XY line. So this point and this point which passes through the same locus will be named as B and C. So now you can see the same side which was lying in vertical plane is now also lying in our horizontal planes. Both the reference plane it is lying. So this is done. But since the given side view is inclined, you have to rotate this side view parallel to our XY plane. Okay, so to get the true shape of it. So what we do usually in projection of lines also, what we used to do when you have the apparent length and angle, we used to rotate that parallel to our XY line. Similarly also you have to do over here. So we'll keep one end of the compass here. Measure from B double dash and C double dash to A double dash to D double dash how much it is. And you take an arc. Measure this distance and you just cut an arc on this reference plane x1 and y1. So you will get one naming over here. So that will be named as A1 double dash and D1 double dash because you're shifting the position. You cannot name the same. This will be A dash and D double dash. This will be A double dash and D double dash. But this will be A1 double dash and D1 double dash. This position. Similarly, you will keep one end of the compass here, measure this distance and you will rotate the given side view parallel to our reference plane. So by using an compass, so you will just cut an arc. So where it meets, it will be our F1 double dash and E1 double dash. So now you got 2 points. So these 2 points has to be projected back. So how will you project this? So for that you should take the help of the projection line from the initial lamina what you have drawn. So you will slightly extend the projection from A dash and you will extend the projection from D dash, you will extend the projection from E dash, you will extend the projection from F dash. After extending the projections from these terms, so you will extend the projection from F1 dash and E1 dash and you also extend the projection from A1 dash and D1 dash. This will remain the same, no need of extending here. Okay, so when you extend the projection with respect to the projection extended from our front view, so you can see where it meets. F1 double dash is meeting F dash projection at this point. So you will name this as F1 dash. Similarly, you have E1 double dash projection which is meeting E dash projection at this point. So you will call this as E1 dash. Similarly, you have the projection of D dash and D1 dash meeting at this point. So this will be our D1 dash. Similarly, you will extend the projection of A1 double dash and it is meeting A1 dash at this point, so this will be our A1 dash, but this B dash and C dash remains the same because B dash and C dash, B double dash and C double dash are also meeting along the same reference plane XY, so no need of showing different points. So after naming this, you won't darken this, but you'll just show how does it look. So you use, don't darken too much, but let it be visible and darker than our projection line. Okay, so you will join C dash to new point D1 dash. From there you will join to E1 dash. From there you will join to F1 dash. From there you will join to A1 dash, and from A1 dash you will join back to B dash. So this is how you have to solve the problem when the information about the lamina position and the side view details are given. So next problem is also same thing. Only the difference here is they have given the side opposite to the side on which it rests is 45 mm above HP. So instead of taking 60° to HP, you will draw a locus for 45 mm, and from then you will just extend the projection where it meets. Okay, so this is the thing what you have to do. So one problem I have given in the assignment already, so you will solve this problem. Similarly, you have do this, only the thing is instead of angle they have given as 45 mm. So this is about one problem on application based hexagonal lamina. Hope it is clear to everyone. Hello. Hello. Yeah, Maraka Hamsini, you want to speak something? Hello.
No, ma'am.
Is it was it understandable, the application problem?
Yes, ma'am. Yes, ma'am.
Okay. So next is we have to try to solve the problem on circular lamina. So everyone know what do you mean by a circle? How does it look like? Right? A circle will be a circular lamina with negligible thickness. If you have thickness, then it comes into the picture of solids. Projection of solids, we call that as a cylinder. Okay, which will be having depth, length, everything. So don't think about that right now. It is just a circular surface with negligible thickness, means it won't be having any thickness. So in the question they give the description with respect to the diameter. Okay, so everyone know how to draw a circle. Only the concept what you have to understand is the given circular lamina could be resting on HP or it could be resting on VP. If it is resting on HP, you will start up with the true shape of the lamina by means of top view. Okay, then we will project that to the front view. And if in the question it is told the circular lamina is resting in VP, we have to start up with the true shape of the lamina in the means of front view, and then we project it down to get our top view. So this is the difference how you have to locate, and this concept is same for all the lamina, whether it is circular, hexagonal, pentagonal, triangular, square, whatever it is. But now after that you have to understand how the position will be described in case of circular lamina. In case of hexagonal or pentagonal, we used to say the side is resting, the corner is resting, right? But in case of circular lamina, you won't be having any side or corner to specify how it is resting. You can just identify the points on the given circumference of the lamina, right? And hence we have to divide the circle into different parts. We can divide it either into 8 equal parts or to 12 equal parts. If you divide to 12 equal parts, you will get a free hand for drawing easily, but it might be time consuming, so you can restrict ourselves to divide it into 8 equal parts also. And one more thing what you have to understand is in the problem they might tell the point is resting on the circumference of the circle in HP. So if they say a point is resting on the circumference, so you'll be having n number of points on the circumference of the circle. So they will specify a point A is resting, a point A on the circumference of the circular lamina is resting on HP. Since it is HP, you will draw the top view first and you will divide the circle into 8 equal parts and you show that the point A is resting on HP. Then you have to start up with the point A. You cannot show the point A over here. Since they have specified the point A on the circumference is resting on HP, you have to show point A. So in that, what you do, first you leave some space, don't go very near to XY line, leave some space and draw a circle with a radius of 25 mm because it is told diameter of 50. So take a radius of 25, identify a center point, using the compass just draw an arc, just draw a circle. So after drawing the circle, you know the center point where it is. Just try to join one horizontal diameter, and again just try to join the vertical diameter of the circle. So you got 2 points. After that, in between you can draw one more line. So any number of line you draw through the center, that will be the diameter only. So again from the center you will draw one line, and again from this center you will draw one more line. So then you have divided now into 8 equal parts. After dividing, since they have specified as point A is resting on the circumference of the circle, please start with point A. So it will be A, B, C, D, E, F, G and H. So after naming, just show the dimension of the diameter as how much it is, 50 mm. Don't forget to show the dimensions. So after showing the dimension, please extend the projections from each point. So when the observer views from here, A will be visible, you will write it as A dash. And when the observer views from here, B will be visible and H will be hidden. So you will write B dash outside and H dash in the bracket. Again, when the observer views from here, C will be visible and G will be hidden. So you will write it as C dash, in the bracket you will write it as G dash. Again the observer views from here, D will be visible, so you will write it as D dash and F dash will be hidden. And here again E will be visible, so you will write it as E dash. So you got the front view for the first stage. Darken it immediately. Since the problem is resting on HP, please start up with the top view, then only go for the front view. So this is about the first stage. So after that, what is being told, the plane is now inclined at 45 degree to HP. Okay, so this was a plane which was parallel to our XY line. So now this plane is now inclined to 45 degree to HP. So you leave some space, fix a point as usual. From this point you take 45 degree using the protractor. After you draw the line, you measure this distance, how much it is. From A dash to E dash, measure the distance using compass. Don't go up with the scale. Keep one end of the compass over here and cut an arc. So after you cut an arc, name it. So this is A dash and E dash. In between you have 3 points what you have to identify. So you measure from A dash to B dash of H dash, what is this distance? Just make a reference point on this line. And again you measure from A dash to C dash of G dash, what is the distance? This entire distance you measure. Keep one end of the compass here and cut an arc. And again you measure from A dash to D dash of F dash, what is the distance exactly? And come back here, fix a point one end of the compass here, and again you make a reference point. So now you got all the 3 reference points. So you name it B dash and H dash, C dash and G dash, D dash and F dash. So after naming, you have all the namings on the plane which is shifted to 45 degree to HP. So now you take the projections down from each point. From A dash, from B dash and H dash, from C dash and G dash, from D dash and F dash. The projection is not visible. You have to take the projection from D dash and F dash and also from E dash. After you take the projection, you have to extend the projection from our top view also. So extend the projection from G, H and F, A and E, B and D, and also C. So all will meet at some specific points. So you will read the locus. Locus of A is meeting A dash at this point. So this is our point A. This is the locus of B, and B dash is meeting at this point. So this is our point B. Locus of C is meeting C dash at this point. So this is our point C. Locus of D is meeting D dash at this point. So this is our point D. Locus of E is meeting E dash at this point. So this is our point E. Locus of F is meeting F dash at this point. So this is our F. And locus of G is meeting G dash at this point. So this is our point G. So you got all the points. If you have constructed the circle properly and done the second stage inclination of the lamina and projection properly, when you join using freehand, you have to draw it freehand only, you will get exact picture. How does it looks? It looks like an ellipse. You have to get an ellipse in the second stage. So now you can see the true shape of the circular lamina is achieved in the first stage of a top view. But now since the plane is inclined to particular angle, the lamina will be compressed little bit. There will be reduction in the area of the circular lamina. So this will be the apparent shape of the circular lamina what you get in the second stage. So whenever you get a problem where the point is resting on a circumference of HP or VP, you will directly do without beta angle. But if it is a problem on diameter, you can see the true length of the diameter here is different, and the length of the diameter what you're getting in the second stage is different. It is compressed. So this is the apparent length of the diameter what you are getting, and this is a true length. So whenever they say the diameter is inclined to 60 degree, 40 degree or 45 degree to VP, then it is a problem on apparent angle calculation. If it is a problem on point A resting on one of its side, so then it is a problem on regular problem, because here also the third inclination is resting point makes 60 degree with HP. So I will explain that. I am just telling you the differences for the location of the points. So now this second stage is over. Now after second stage, you have to see what is being given. The top view of the diameter passing through the resting point makes 60 degree with HP. So this is the top view at which it is resting. It is resting at point A. So this point is now making an angle 60 degree with VP. So we have to shift the point A to 60 degree to VP. So you have to take 60 degree line. After drawing 60 degree line, you have to fix the point A either this side or this side. Okay. So first what you will do, you will just take an 60 degree line. After taking 60 degree line from XY plane, you fix some point convenient below the XY line as A. Because in the question it is told the resting point, this is a resting point A. So the resting point is now making an angle of 60 degree with VP. So please take 60 degree to VP and identify a point as a resting point and name it as A. So now you have shifted to the 60 degree line. So after you shift to 60 degree line, you have to construct now the second stage into the third stage. So you can construct by using box method, or you can just identify the points. So after you draw 60 degree line and identify A, you measure this distance from A to E is how much? On 60 degree line, you just make a reference point. So you will get point E also. After you locate AE, please try to identify. So if here you will be having the locus of H and B, here you will be having the locus of F and D along with G and C. So all these three construction lines should be drawn perpendicular over here with respect to 60 degree line. So here you will be having 60-degree line. So then you have to mark this perpendicular lines. I'm just telling you. So this perpendicular line has to be drawn. So this perpendicular line has to be drawn. This perpendicular line has to be drawn. With respect to the perpendicular lines, what you have in your second stage, all these three perpendicular lines what you have, right? So that you will be drawing over here. So this will be our 60-degree line. On 60-degree line you will fix the point A. After you get A, you will measure from A to E is how much using compass, and you make a reference. So you got A and E. After that you identify from A to this distance what is the distance and make a reference point. And again from E to this point what is the distance, make a reference point. And again from E to the center what is the distance, make a reference point. You got all the three reference points. Once you got all the three reference points, just draw perpendicular line to our 60-degree line. It should be exactly perpendicular. I have shown you only roughly. Okay, so after drawing the perpendicular lines, now it's very easy. You know E and A, so identify the other points. So from this point to F, what is the distance you measure using the compass? Come back to this point and you just cut an arc on the perpendicular line what you have drawn. And similarly from this point to D, it will be the same as from here to F. So measure this distance how much it is, come back to this position and you cut an arc on the perpendicular line what you have drawn. So name it as